Welcome back to our geometry series. Today we are up to section 6.6 where we will be looking at circle and segment lengths. In previous videos we have looked at a figure like this where we have circle O and two chords creating an angle, and we would ask questions about this angle. This time we're going to focus on the chords themselves. And that leads us to our first theorem of the day, Theorem 80. If two chords intersect inside a circle, like we have here, then the product of the lengths of the segments of one chord is equal to the product of the lengths of the segments of the other chord. Okay, wait, what does that mean? Let's break it down. Let's start with the first part here. The product of the lengths of the segments of one chord. So let's look at one chord. Let's look at chord AB. And then the two segments that make up that chord. Segment AT and BT. We're going to multiply the lengths of those together. So the product of the lengths of the segments. So AT times BT. That is equal to the product of the lengths of the segments of the other chord. So we take the segments of DC, the other chord, those two segments being DT and TC, and multiply those together. Let's do a quick example. Here, the length of DT is 6, the length of AT is 10, and the length of TB is 9. So we can substitute those into the equation we have here, like this. So we're trying to figure out what is the length of segment TC. We can simplify the math and find out that TC is equal to 15. Next, let's take a look at two secants, secant dt and at. And that leads to Theorem 81. If two secants intersect in the exterior of a circle, then the product of the lengths of one secant segment and its external segment is equal to the product of the lengths of the other secant segment and its internal segment. Again, let's break this down. One secant segment, in yellow here, would be dt. And its external segment in purple is BT. So you take the entire length of the secant and multiply by the length of the external part. Likewise, secant AT will be multiplied by its external segment length CT. So again, another example. In this case, we need to be careful. DT is the entire length of the secant. So looking at the figure, you have to add the 5 and the 3 together to get the entire length of dt. Then you multiply it by the external segment of that secant, which is 3. Likewise, for AT, the entire secant, it's going to be 2 plus x, the thing we're trying to figure out. You need to multiply that entire quantity by the length of the external segment CT. So we get into some algebra here and end up with 24 equals 4 plus 2x. It simplifies to 20 equals 2x, or x is equal to 10. And really, x is what we're trying to find, is the segment length AC, which is 10. Finally, let's take a look at a secant and a tangent. That leads to our final theorem of the day, Theorem 82. If a secant and a tangent intersect in the exterior of a circle, then the product of the lengths of the secant segment and its external segment, like what we did in the previous example, is equal to the square of the length of the tangent segment. So dt times bt would be equal to at squared. So again, we'll put some numbers in here. Again, we need to be careful because dt is the sum of db and bt. 19 plus 17 gets us 36. Then we multiply by the length of the external segment, 17. It would be equal to the square of the length of the tangent. So that we're just replacing it with x. So we end up with 612 equals x squared. And in cases like this, I like to use Mr. Calculator, and we end up with x approximately equal to 24.7. Again, x was the mystery length we were trying to find, which is AT. let's jump over to the whiteboard and do some examples. Alright, we're going to start with a circle up here like this-ish. Circle O. We're going to draw two chords like this. And this length over here is going to be x. And this short length will be 4. This longer length over here is going to be 10. And this length over here will be x plus 3. Make that a better x. So we're going to use theorem 80. We know that when two chords intersect in a circle, the product of the lengths of one chord is equal to the product of the lengths of the other chord. So let's look at this chord first. So that means that 10 times 4 is going to equal this times this. X times x plus 3. So we'll kind of expand this out. This is 40 equals x squared plus 3x. So we're going back into our algebra fun here. We're going to subtract 40 from both sides. X squared plus 3x minus 40. So we need to factor this. We're going to have an x and an x. So we can do x plus 8 and x minus 5. 8 times negative 5 is 40. We're going to end up with an 8x and a minus 5x. It gives us a 3x. So in this case, we know that x has to equal 0, when we need to multiply it out. So this would have to be negative 8 or 5. Those are the two answers. So it's negative 8 or 5 would make this equal to 0. But we're talking about actual real distances, in real world. You can't have a negative distance. So in this case, x is equal to 5. So in that case, this up here is 5, and this is 8. Scribble, 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 scribble. All right, let's clean this off and do another example. All right, another fun circle like this. It's a circle O, of course. What I'm going to do is draw two secants that intersect on the exterior of the circle, way out here. We're going to say that this is 20, this is 14, this is 11, and this is the length that we're trying to find. And this time we're going to use theorem 81. If two secants intersect on the exterior of the circle, then the product of the lengths of one secant segment and its external segment is equal to the product of the lengths of the other secant segment and its internal segment. So the whole thing times its external is equal to the whole thing times its external. So let's just write that out. So the whole thing up here is 20 plus 14. So we have 34 times just the external bit, which is 14. It's going to be equal to this outside part, which is x plus 11. Remember, you have to add up the whole thing times the external part, which is 11. So 34 times 14 is 476. And then we'll expand this out here as 11x plus 11 times 11, which is 121. Subtract 121 from both sides, we end up with 355 equal to 11x. So we'll probably use a calculator for this because this isn't a happy multiple of 11. And we end up with x, approximately equal to 32.3. That's out here, 32.3. All right, let's clean this off and do one final example. Okay, last circle of the day, like this. O. And what we're going to do is draw a secant out to here-ish. And then I'm going to draw a tangent from this point of the circle out to here. And of course, now we're talking about theorem 82. So if a secant and a tangent intersect in the exterior of a circle, then the product of the lengths of the secant segment and its external segment are equal to the square of the length of the tangent segment. So let's say we want to figure out this chord from here to here. But we know what this chunk is, and and we know the length of the tangent. So again, it's the entire length, x plus 3, times the external part, which is 3, is equal to the tangent squared, 6 squared. So let's expand this out. 3x plus 9 is equal to 36. We'll subtract 9 from both sides. 3x is equal to 27. And then x is equal to 9. And we can put that up here if we want to. 9. That's it for today. It's a pretty short section. We'll see you next time.